Hello, my lovely students. So here is my first video being recorded after the snowstorm. I hope all of you are safe and warm. Remember, take care of yourselves first, then worry about everything else. Let me know if there's anything I can do to help. Seriously. All right, so here we have a crash course in geometry. So there's going to be a bunch of definitions, but y'all know me, I'm not the type to do definitions. And since you guys get a cheat sheet, it'd be kind of silly. But you should be familiar with the idea behind these. So I don't expect you guys to regurgitate it, but I do expect you to understand what it's talking about. So an angle, the intersection of two lines or line segments forms an angle. Whee! So line, line. There's actually four angles. There's one here, one there, one here, and one there. And those ones that are opposite that look like they're equal are actually equal. And then the point of intersection where the two lines or line segments or rays is the vertex. So in this case, all four of those angles share the same vertex. Yay, words. Okay, now we have special types of angles. There's a small possibility that Alex will pick a different name for the 180, but the 90 degrees we should know. It makes a right angle. Then the 180 here, it's sometimes called a straight angle or a straight line. It is a straight line. That is the way the drawing is supposed to be. Maybe straight line angle. I mean, they can't make up their minds on what they want to call it. Most of the time we just call it a line because that's what it is. But the measure of the angle of a line, if you put a thing and call it a vertex, is 180 degrees. You can think of it as half a circle because I can cut a circle in half and I know a full circle is 360. So cutting it in half gives me two 180s. Now these next two, the names they're fishing for, and this is not the way your homework would look. This is just the way the question got set up. This is an acute angle. Oh, I know, I'm horrible. So acute angles measure less than 90 degrees. And then what we call obtuse angles measure greater than 90 degrees. Now in FUFU advanced math, which you may or may not have seen, we sometimes actually talk about, like I was just talking about, a circle is 360 degrees. So we can't actually draw an angle and talk about the one that's bigger than 180. But when we draw that, like technically, here, let me put it in here. Like that, what they drew there is 135. Technically, there's also this really big angle that is 360 minus 135, which is 225. Not the kind of thing they'll ask, but usually we reserve obtuse for between 90 and 180. And then acute is between 0 and 90. Like technically you can even talk about negative, but we're not going to get that crazy. I'm just throwing it out there in case your brain has that vague memory that this was a thing. Yes, it was a thing. But otherwise, no, you don't need to know the thing for this. All right, so now we're going to talk a little bit about circles. So circles have radiuses and diameters. Radii. Yeah. Ugh. So the radius of a circle is the measure, the line segment, the length of the line segment from the center to any point on the circle. the diameter of a circle is the distance of the line segment that goes across the circle and through the center. But a lot of people remember this, that this is really just, it's two radiuses. Or radii. So let's doodle a circle. That is a horrible circle, but we're going with it. And then somewhere in there is our center. So if I take any straight line, I know I can't draw straight lines on the computer, just bear with me. But any straight line from the center to a point on the circle is a radius. So we'll give that an R. No, we'll try to write the horrible word. Okay, radius. Now, any line I draw that goes through the center and then touches both sides of the circle, that full length is the diameter. But I can draw it any which way. So as long as I go there, if I stop there, that's a radius. But if I keep going on the same presumably straight line, then that would be the diameter. So if we talk about a radius or talk about a diameter, that's what we're talking about. We need to know, we use one for one thing, one for another thing a lot of times. I just prefer to stick with radii. It's the one you get most often. Now, polygons are, this is probably one of the most peculiar technical definitions, but the like short, quick, down and dirty is an enclosed figure. Made up of line segments that like connect in a chain and back to the beginning. So sometimes I like to think of this as a bunch of straws on yarn. So you feed a whole bunch of straws on yarn, and then you tie the yarn super tight so that the straws on the end touch. And then you lay that down, so all the straws are straight, there's a polygon. And by the technical definition of polygon, it doesn't matter how the straws end up, except they can't cross each other. Now in math, we generally deal with what are called convex polygons, which means we don't get a bit that eats inside like a weird Pac-Man kind of thing. So and we'll give it a little roof there. That is a polygon. That is a 5-sided polygon. I've got a couple right angles, and then I got my roof where they're not right angles anymore. But I could also draw the very peculiar looking, still the same 3 sides, but now the roof caved in. Both of those are polygons. The first one is called a convex polygon. Not that you guys need to know that, but if you do any Googling, they might throw this word in front of it. That's an X, not an S. And then these are sometimes called concave polygons because it caved in. Now, a regular polygon satisfies the definition of a polygon, but all of the sides are equal and all of the angles are equal. So my little house diagram up here, or even my convex one, both of those could be all equilateral, but they are very, very not equal angular. The angles are not the same there, but the side measures could be. A regular polygon is a polygon in which all the sides are equal. And then I'm going to write what the fancy math term, equilateral. And all the angles are equal, meaning they're equal to each other. They're all the same size. And then sometimes we use the fancy math word equiangular. I think there's an L in there. Maybe not, but it looks weird without the L. No, it doesn't. That's it. Equiangular. All right. So draw an example. Look, magically, I have produced 6 examples, mostly. So it's just like all your straw lengths are the same, and then you situate them so they all are like the same distance from each other. So you haven't put 2 of them really close together. Each one, the angle between 2 of the sides is the same in the whole arrangement. So like a square, each angle is 90 degrees, and those 4 90 degrees would add up to 360. Or with a hexagon, each interior angle there is 120 degrees. So every single one. All right, so draw an example. Then we have fancy names. We know this one. It's a triangle because it has 3 angles. Now, number 4, our 4-sided figure. The really fancy math word is quadrilateral, but colloquially, this is known as a square. There are many kinds of quadrilateral, but the one that the sides are equal and the angles are equal has the nickname square. Now down here for our 5-sided figure, this is a pentagon. 6-sided figure is a hexagon. And then we know our good old-fashioned stop sign, octagon. I should have gotten my daughter to voice over this. She would have been so happy. But YouTube gets weird about having kids in videos, so. And decagon. Being able to name them is not important, but we have this just in case they ask. I have heard 7 called a heptagon, so it's H-E-P-T-A-gon. I've heard a 9-gon called a nonagon, but generally, like, if they don't have these fancy names, we just start saying 11-gon, 12. We know that's a dodecagon, but sometimes we'll just write 12-gon because we're going to be talking about crazy figures and we don't want to keep coming up with names. Okay, so we're going to pause this and then come back in the next one.